Namaste. This is JV and Dr. Vishal Saxena, Associate Professor in Mathematics and Statistics in Jayoti Vidyapeeth Women's University, Jaipur. Today I am going to discuss about the module Regression Analysis. Regression analysis refers to assessing the relationship between the outcome variable and one or more variables. The outcome variable is known as the dependent or response variable and the risk element. The risk elements and and confounders are known as predictors or independent variables. The dependent variable is shown by y and independent variables are shown by x. In regression analysis, the sample of a correlation coefficient is estimated in the correlation analysis. It ranges between -1 and +1, denoted by R, and quantifies the strength and direction of her linear association among among the two variables. The correlation among two variables can either be positive, that is, a higher level of one variable is related to a higher level of another, or negative, that is, a higher level of one variable is related to a lower level of the other. The sign of the coefficient of correlation shows the direction of the association. The magnitude of the coefficient shows the strength of association. For example, a correlation of R equal to 0.8 indicates a positive and strong association among two variables, while a correlation of R equal to -0.3 shows a negative and weak association. So that means R equal to -0.3 due to negative sign, it shows a negative and weak association, while R equal to 0.8, which is a positive value, indicates a positive and the strong association among two variables. A correlation near to zero shows the non-existence of linear association among two continuous variables. And we can see if the value of R equal to 0, then or just near about 0, then it shows the non-existence of linear association among the two continuous variables. Now next we discuss about regression analysis, a statistical measure. Regression analysis is a statistical measure that we are using in investing, finance, sales, marketing, science, mathematics, etc. It tries to determine how strongly related one dependent variable is to a series of other changing variables. We usually refer to them as independent variables. The dependent variable is the one that we focus on. Put simply, we want to know whether it is being affected, and if so, by how much and by what. Independent variables are the variables, independent variables are the factors, or we can say variables that may or may not affect the dependent variables. Dependent receive Dependent receive the impact while independent provides or not the impact. Now next we discuss about the part of the linear regression of the linear regression. Linear regression is a linear approach to modeling the relationship between the scalar components and one or more independent variables. So it means the linear regression is a approach which is linear in nature and to modeling the relationship between the scalar components and one or more independent variables. If the regression has one independent variable, then it is known as a simple linear regression. If it has more than one independent variable, then it is known as multiple linear regression. So, multiple linear regression will have more than one independent variable, while the simple linear regression will have only one independent variable. Linear regression only focuses on the conditional probability distribution of the given values rather than the joint probability distribution. So it is very important point that the linear regression only focuses on conditional probability distribution of the given values instead of rather than the joint probability distribution. In general, all the real-world regressions models involve multiple predictors. So the term linear regression often describes multivariate linear regression. Simple linear regression follows the equation of a straight line which is given below y equal to mx plus c. So this is the equation of a straight line and the simple linear regression follows this equation. In this equation we have y is equal to target, that means the dependent or the criterion variable. So y shows the dependent variable and x is the independent or the predictor variable, while m is equal to slope or the regression coefficient and c is equal to constant. Multivariable linear regression defines the relationship between the outcome variable and more than one independent variable. It follows the below equation of a straight line where dependent variables are the linear combination of all the independent variables. So y is equal to m1x1 plus m2x2 plus m3x3 and plus mnxn plus c is the equation where y is equal to target or the dependent or the criterion variable, while x1, x2, x3 and till xn are the independent or the predictor value variables. So m1, m2, m3 and till mn shows the slope or the regression coefficients of respective respective variables and c shows the constant. Linear regression follows the principle of least square method. So it is very important point to be noted that the linear regression follows the principle of least square method, and it is very important method in mathematics, and linear regression follows this principle. This method states that a line of best fit is chosen by minimizing the sum of square error. The line of best fit is chosen where the sum of square error between the observed data and the line is minimum. So according to this method of least square, that a line of best fit is chosen by minimizing the sum of square error, and the line of best fit is chosen where the sum of square error between the observed data and the line is a minimum. Now we have a diagram, and this diagram shows that regression analysis and it can be just divided into three parts like linear regression and the multiple linear regression and non-linear regression. So linear regressions, linear regression, uh, linear regression and the multiple linear regression and non-linear regression are the three parts of the regression analysis. Now next we discuss about the regression analysis linear model assumptions. So what are the assumptions for the linear model in the linear regression analysis? We take First assumption is the dependent and the independent variables show a linear relationship between the slope and the intercepts. So the dependent and the independent variables show a linear relationship between the slope and the intercept. Second is the independent variable is not random. Third is the value of the residual or the error is zero. Next point, the value of the residual or the error is constant across all the observations. Number fifth assumption is that the value of the residual means error is not correlated across all the observations. Next point is the residual or the error values follow the normal distribution to predict the sales and the revenue is in any sector for shorter or the longer periods to predict the customer churn rate of the any industry and find out the suitable measures of reducing them to understand and predict the inventory levels of the warehouses to find whether introducing a new product in the market will be successful or not to predict whether any customer will default loan or not to predict whether any customer will buy a product or not. So these are the some assumptions taken in the linear regression model, and so these are very important assumptions for the linear regression analysis. And we see these linear the assumptions one by one, very important. One is here like the dependent and the independent variables show a linear relationship between the slope and the intercepts. The independent variable is not random, and the value of the residual error is zero. The value of the residual or the error is constant across all the observations. The value of the residual or error is not correlated across all the observations. So it is important point that the value of the error is not correlated across all the observations, and the error values follow the normal distribution. The normal distribution is a probability distribution and which is continuous in nature to predict the sales and revenue in any sector for shorter or longer periods, and to predict the customer churn rate of any industry and find out the suitable measures of reducing them to understand and predict the inventory levels of the warehouses. So these are just some assumptions taken in the model of the regression. And regression analysis is very important part of the mathematics, and it is used in all the subjects in the all the fields of mathematics, and it is related with the correlation analysis. Now we take one example to understand this. Question is calculate the regression coefficient and obtain the lines of regression for the following data. So in this table we are given that a table is given that and thus we are required to find the regression coefficient and lines of regression for the following data. So according to this question, a table is given that for the two variable x and y, and for the two variables x and y, the values of x are 1, 2, 3, 4, 5, 6, and 7, while the values of y are 9, 8, 10, 12, 11, 13, and 14. So when we have to find the regression coefficient and the lines of regression, so first we have to make a table for the variables x and y, then x square, y square, and x to the power y, or multiple means xy. So we are making a table for these variables, like the values of x are given by 1, 2, 3, 4, 5, 6, and 7. These are the given values of x, and the given values of y are 9, 8, 10, 12, 11, 13, 14. So these are the values of y: 9, 8, 10, 12, 11, 13, and 14. And now we calculate the values of x square, y square, and xy. So values of x square are 1, 4, 9, 16, 25, 36, and 49, while the values of y square are given by 81, 64, 100, 144, 121, 169, and 196. The values of xy, product xy is given by 9 into 1 is 9. In the same way, it becomes 16, 30, 48, 55, 78, 98. So these are the values of xy. And now at the bottom we have to find their summation. So summation of x is equal to 28, summation of y is equal to 77, summation of x square is equal to 140, and the summation of y square is equal to 875. Summation of xy is equal to 334. So as per the requirement of the formula or the concept, we have to find these values uh, like summation of x, summation of y, summation of x square, and then summation of y square, and summation of xy. So summation of x upon n is called x bar, that means mean. So mean of series x is given by x bar, and x bar is equal to summation x upon n, which is equal to 28 upon 7, and this is equal to 4. While y bar, that means it is the mean of the series y, and which is equal to summation y upon n. So value of summation y is there 77, and the value of n is there 7. So there are total number of data. So 77 upon 7, and which is equal to 11. Now next, the regression coefficient of x on y. So now we will find out the regression coefficients, two regression coefficients. One is bxy and one is byx. So the regression coefficient of x on y bxy is given by this formula: n into summation xy minus summation x into summation y upon n into summation y square minus summation y whole square. So the value of n is 7, while the value of summation xy is 334. We have found in the table summation xy, that is 334, and the value of summation x is there 28, the value of summation y is 77, and upon n into summation y square. So the value of summation y square is 875, and the value of summation y is 77. So now we have to put the values in this formula, like the value of n, summation xy, summation x, and summation y, and the summation y square. So just we have to put the values in this formula, and when we calculate, so we will get the value of bxy is equal to 0.929. So the coefficient bxy, which is also known as the regression coefficient of x on y, and we have found its value as 0.929. So now we will find the regression equation of x on y. we have to find the regression equation of x on y, and this equation is given by x minus x bar is equal to bxy into y minus y bar, where the x and y are the variables of the equation, and every equation will have the variable parts. So x and y are the variables, and x bar and y bar are the mean values of the series x and y respectively. So x bar is the mean of the series x, while y bar is the mean of the series y, and bxy is the regression coefficient of x on y. And in the similar way, the regression coefficient of byx is called the regression coefficient of y on x. So now we have to put the values which we have found earlier in the above part of the solution. So x minus 4, 4 is the value of x bar, and the value of bxy is 0.929, and y minus y bar, the value of y bar is equal to 11. So just when we solve this equation, so we will get x minus 4 is equal to 0.929 y minus 10.219. So the values of the, when we put the values of different terms, then we will have the equation x minus 4 is equal to 0.929 into y minus 11. And after solving this equation, we will get x minus 4 is equal to 0.929y minus it becomes 10.219. And just we have obtained in this way the equation of the first regression equation, and this is the regression equation of x on y, and it is given by 0.929y minus 6.219. 0.929y minus 6.219, and which is equal to x is the first regression equation and known as the regression equation of x on y. Second, now we will find the regression coefficient of y on x. So this is the second regression coefficient, and it is known as the regression coefficient of y on x, and it is given by byx. It is given by byx, and this is equal to n into summation xy. So n into summation xy minus summation x into summation y upon n into summation x square minus summation x whole square. This equal to 7 into 334 minus 28 into 77 and upon 7 into 140 minus 28 whole square. So these are the values just written by the above table, and where just we have calculated these values. N represents the total number of data, which is 7, and the value of summation xy is 334. Just we have found these values in the table above. This is the table. So the value of summation xy is equal to 334 minus the value of summation x is equal to 28, and the value of summation y is equal to 77. Then n is 7 and summation x square is 140, and the value of summation x is 28. So when we put these values in this term in this equation, so b by x will become ultimately 182 upon 96 after solving, and which can be further simplified, and we will get the value of b by x as 0.929. So b by x is equal to 0.929 is the value of second regression coefficient, and it is known as the regression coefficient of y on x. The regression coefficient of y on x. Now next part is the regression equation of y on x. So the regression equation of y on x is given by y minus y bar is equal to byx into x minus x bar. So this is the line of regression of y on x. So we have to put the values of x bar and y bar. So these are 4 and 11. So when we put the values in this equation, we will get y minus 11 is equal to 0.929 into x minus 4. And when we solve this equation, we just when we make the calculations, we will get the y is equal to 0.929x minus 3.716 plus 11, and which is further on simplification becomes y is equal to 0.929x plus 7.284. So y is equal to 0.929x plus 7.284. So in this way, we have just found the two regression coefficients and the two regression lines in this example. And now we take the part of differences between correlation and regression. So now we discuss about the point of difference between correlation and the regression. And the first point is correlation shows the quantity of the degree to which the two variables are associated. So it means that the correlation shows the quantity of degree to which two variables are associated. It does not fix a line through the data points. And we compute a correlation that shows how much one variable changes when the other remains constant. When r is equal to 0, the relationship does not exist, means in the case when the r is called the coefficient of correlation, and when its value is 0, then it means the relationship is not existing in that case, and the two variables are not called correlated. While when r is positive, one variable goes high as the other goes up. When r is negative, one variable goes high as the other goes down. So it means for the positive values of r, the correlation is called positive correlation, and in that case, when one variable increases, then second variable also increases in that case. And in another case, when the value of r is negative, when one variable goes high and the second variable goes down, that means when the uh, when we increases one variable, then in the negative correlation, the second variable will get decreased. Linear regression finds the best line that predicts y from x. So this is the point this is the important point that the linear regression finds the best line and which predicts y from the values of x. Correlation does not fit a line. Correlation is used when we measure both variables, while linear regression is mostly applied when x is a variable that is manipulated. So these are the points of difference of correlation and regression. And just we have seen there, we have discussed 3 points of differences in correlation and regression. And correlation is an important part of the mathematics, as similar to regression is also a very important part of the mathematics. And regression just gives a functional relationship between the two variables, and to understand the regression analysis, we have to understand the concept of the uh, least square method, and we have to discuss about the two lines of regression. We have to understand the two lines of regression with the coefficient of regression, and the equation of line of regressions. The two lines are called one line of regression of y on x, and the second line is called the line of regression of y on x. With this, I conclude today's session. Thank you.